everyone doing? Hey, I still have no idea how to set up a green screen, but at least the audio issues should be solved now, I think. So anyways, first of all, I set up something really cool which should work. Let me try it out in chat. I'm going to say, well, you can see the chat, you'll see what I'm doing. And basically, there's a minigame now, so you can be entertained while I code. And yeah, basically you can say exclamation drop and a random emoji, or just exclamation drop to send your character flying down the screen. If you get into that target, you get channel points that you can use to... I mean, for now it's not that much, like you can make me drink water and stuff, but those will be worth something at some point. So yeah, that's a thing now. There's like a 90-second timeout, so you can keep dropping indefinitely. You have to wait 90 seconds after before running it again. But yeah, hopefully that will make things a little more interesting. Yeah. Nice to see some people. I'm also going to be eating a little bit because I haven't had time before the stream. So yeah. Nice, you got the high score. So yeah, anyways. Today, we're doing music. What does that mean? I have no idea, basically. I saw this really cool article about the web audio API. Which basically allows you to create sound from nothing, more or less. Like you use noise, you use Perly noise, you use this static sound that TVs had. You landed in the exact same spot. And you use that to make cool things. For example, here you can see white noise. I may have to pause the music for that. Yeah, white noise. So this is created entirely from code. Then you get to use that white noise to do a snare drum, kind of, or a kick, which is hard to hear, but like it's there. And then with that you end up, well, I can't even hear that. You end up oh, there it is. You end up using it to create actual notes using frequencies. I don't know if that's hearable. Like it's showing really tiny in the volume meter, but it should. Let me know if I have to turn up the volume for that. But yeah, and you basically learn a lot about music theory, and then you get to make these things sound different and stuff. And so I thought, this is really cool. I should do a stream where I try to figure it out with others together, following this guide. And that's what we're going to do. So yeah. This is like... There's this amazing article by Josh, which is like a dynamic introduction that we're also going to be looking at, just because the animations and explanations and everything is gorgeous. And yeah, it's like super interactive and stuff. So that's what we're doing today. We are doing music. Kind of. So, let's get started. Let me bring back the music. Oh, and also I actually made a playlist that shouldn't get copyrighted this time. Like I made... It's insane, actually. I made a 7.5-hour playlist of music for the stream that has like these Twitch stream gamer vibes, but also shouldn't be copyrighted, and I guess we'll find out which ones are copyrighted, and over time I will get better at it. Just cause Twitch will complain about me and mute the parts that are actually copyrighted. But yeah, let's get started. So I think first of all we're going to go through the waveform guide, just because that's going to be helpful later when we actually do things with waveforms. So yeah, let's see. We're going to be skipping most of the text though, and just look at the actual examples and what it tells us. So of course this is like a graph that tells the displacement of the noise over time. This is time, and this is the... Hey, hello from London, Lenore the Third. Oh, and thank you for the follow, Clen3 Lord Bimbo, if you are still here. So yeah, x is time, and since this is a sine wave, or it's like loopable, it starts and it ends at the same point, so we only need 1 second, or whatever the frequency is. We'll look into that later. And then the displacement is, if you imagine the string of a guitar, when you pluck it, it goes back and forth, so that's basically what this is representing. It's supposed to be related with loudness, I think, but we'll look into that later. So we have the amplitude, which correlates with like the strength of the sound, kind of. The more the air moves around us, the louder the sound seems. And so if we make it less ample, you will see that it basically makes it squishes it on the y-axis. So this will... I actually can... Let's pause the music for a second. Get this up and unmute this. So I don't know if you can hear that. I can, but it's not really... Or is it? I have no idea how the sound works. Like, I'm not hearing the things at the same volume that you are. So let me know if that's too loud or not. I think that may be a little bit too loud. I think that should be better. So yeah, no sound. I mean, little bit of sound. A lot of sound. A little bit of sound. So frequency is the time that it takes a full iteration, like going... Can I pause this? I think I can. Going from up to down and then back up. And so this correlates with the pitch, I think. Yeah, it correlates with the pitch. So if we get the slider here, let's turn down the volume a little bit. This is high pitched. This is very like bassy. So yeah, that's basically how fast the graph goes, like the time it takes it to go the entire sine wave, and that's the pitch. Let's mute that for now. So this is an explanation about how sound works, which I already understand and we don't need to go through, but basically if each dot in this grid is like an air molecule floating around, you can see that there are waves passing through it when it moves. So that's basically how sound works, really. And you can see here, if I put more frequency, it vibrates more often, and if I put more or less amplitude, it it goes faster or slower, kind of. So yeah. Now the hard part, the part that I don't really. Oh wow! When did the chroma get this bad? I thought the transparency was better. Let me fix that. Actually, playing it with the lights might fix that. There we go. That's slightly better. That is slightly better. Still, I feel like I always end up tweaking this on the fly as we go, which is not ideal. Something like this should make me slightly transparent, but that should be good, I think. Let's bring a little bit color back. That's better. And let's move me more center. There we go. So, we have been using science for now. Basically because that's pure. That's like there's nothing going on in there except for a full frequency. So we can, like you can see here, is basically all of it is on the same place. And so what we can do is use different waves, types of wave. You can kind of tell with the sound. This sounds more rough, more electronic in a sense. And that is because it's not just going from, it's not just making the sound at exactly one place. It also has a little bit of fall-off on other frequencies, you can see here. So before it was just one and nothing on any of the others. Now there's a little bit on the harmonics, which is something that I don't really understand and we'll have to understand later. Then we have a square waveform, which I'm going to mute because this one's really annoying. That's different. That instead of going with the, I think it's pure harmonics, or the harmonics, the fundamental, which is the one that we are actually targeting, second harmonic, third harmonic, etc., etc., etc. We're going with the odd harmonics, which are the ones that are not actual harmonics, I think. We have another one. These sound all really annoying. So this one basically is more of like it's every multiple of the root frequency, whatever that means. You get the visual representation. You don't have to understand the words. I don't either. So yeah, now finally we have we can combine them. We can layer them on top of each other. And for this, we need to understand how you can add waveforms. Here we have two waveforms. And to add them in, and take, this is like the same representation. Here they're together, and here we see the sum of them, the combined form. So you can see it's kind of like averaging out these shapes onto the top ones until they are the same one. Yeah, we can add more. What we can basically do is add more. And when we sum them, it will give us different shapes. And then we go to something really similar to the, let me mute this, similar to the square ones, not exactly, because like there's infinite here, but it's similar enough so that it sounds still annoying. So then we have the face, which is right now these are like kind of offsetted. Like you can see they start, or I mean, kind of here they are offsetted. They start and end at the same time. We have the face, which is we can offset them. Something really interesting about this is that if we manage to put them so that they are exactly half of a face offset and we convert them. I mean, I didn't do that properly. Yeah, there we go. It converts to 0. This is actually how noise cancelling works. Noise cancelling, basically what it does is it has some microphones, and those microphones play to you the sounds that you see on the outside, but shifted. Like you can see here, we shifted the phase. So if these are the sounds that you're seeing, that you should be hearing, for example, these headphones, what they do is they record that and they play it in real time, but with the phase offset. And when you average them out, if you do it correctly, it mutes them. That's how that works. And that's how I believe computers do it, so that you don't hear yourself on video calls. Like if you're using the computer's mic, you don't hear the computer speakers. I think that's how that works. I know it's for sure how the headphones work. So yeah, convergence, phase, and here's the note. This is how noise cancelling works. Finally, we have chords. Which are basically made of specific frequencies. This is a C major. And yeah, that's it. Now we get to the fun part, which is we have all these concepts. We need to put them to work. We need to make something with it. We need to make music using JavaScript. I mean, it's not music, that's a little clickbaity. It's more of like we're making noise, or we're making notes. We're making a synth, basically. And also remember, you can drop, because that's fun. But yeah. I'm going to go to the code sandbox, basically because I want to see the structure that they are using. I think I can see these arrows here, can I? I cannot. Maybe there's a link. Anyways, so let's just use an example JavaScript project. And I can turn the music back on. With the time that I spent creating that place, I might as well use it. So let's make a new directory and let's call it let's see. I think actually using next.js might be the best thing here, because like you get a quick reloads easily. So let's create a new Next app, even though we are using literally none of Next's features. And there's someone in there in the middle of my face, but that will go out in 90 seconds when you can retry. So yeah, let's call this web audio. Oh, and by the way, if someone manages to get the drop, like to actually land on the target, let me know if your channel points increase and how much. Because like it should, but I haven't tested because I have infinite points obviously. So it would be helpful to know if it actually works. Oh yeah, sorry, I muted it so I could eat in peace and quiet and not bother you with like chewing sounds. I was saying that I don't know why this took so much to install today. Like next, it usually is quite faster, but we are done now. So yeah, let's clean this up a little bit. We're not going to need Tailwind or any of those things really, because we are just using. We're not going to need the API. We don't even need underscore app actually. I'm going to add in prettier, because of course I will. And yeah, let's also, we can get rid of this too. And in here we're going to have a component called index. That's nice and easy. And let's just have it return hello world for now. That should be get started pretty fast. Oh, let's enable Webpack 5 so that it's even faster. There we go, now it should be even faster. Let's get a reload. It's going to take some time to build. No one is getting to a target now. Better luck next time. Yeah. There we go. Hello world. Let's get started. So the first thing we need is an audio context. So let's bring that in, and I don't know if that's going to make it to be an issue with a next server reload thing. If I give this a reload, yeah, it will. So let's say if we are on the server, we're going to just return server. And we can add anything here, and it will load fine. I mean, we will get this warning, but it doesn't really matter. So yeah, let's get started. We have our audio context. The next thing we need is a buffer. So we're just going to copy this and figure it out as we go. Basically we have a sample rate, which is just the audio context sample rate, but we need to specify twice. I think we still don't need a variable for that. Then we have the time length, which is seconds, and it's going to be 1 for now, because we want this to last 1 second when we press it. And then, I mean, we don't want to read it, really. I mean, I guess we can console.log that out. Make sure it's actually working. So this is an empty buffer. You can see it's just zeros. To propagate that and to basically have this static noise. Static noise is just like purling noise, which is I mean, it's not actually. This is the one, static noise. Is this noise but translated to audio. So basically how this noise works is like, for any of these points, you get an image, you take all of the, you loop a function through all of the of those points, and I think I need to move my phone. So basically imagine I'm writing code that generates this. I can write a function that will run for every pixel in this image, and for every pixel we just generate a random number between 0 and 1. So 0, 0.05, 0.0006, and then you color the pixel black or white depending on the image. So that's how this noise is generated, which is actually really fun, and we should do a stream on shaders sometime because they are really fun. I think there's like a spot that is not covered by the chroma for some reason. Oh right, there we go. So yeah, for audio we want to do the same thing. So we are basically going to loop through this buffer. You can see here this buffer is just empty, and assign a number between -1 and 1. So let's do this here. We're going to do math random by 2 -1, which will basically get us a number between -1 and 1. And channel data is not defined. Oh, I need to get the channel data first. Okay. So if we log the data now, you will see it's like just random numbers, really. And Ostap, I will reply to your question the next time something is loading, so that I have a backlog now. So yeah, random number between 0 and 1, and now when we get to play this, it's going to sound like static noise, really. Like the static noise that we all love. Like you can see, it's white noise. So we are going to use the audio context. And we can simplify this so that it's just one line. Just because it looks nicer. We are going to create a new buffer source. First we created a buffer. The buffer has some data. Now we're creating a source for that buffer and assigning the buffer to the buffer. Kind of complicated, but we're basically creating a source and plugging our buffer into the source. And then finally, I mean, we have to do something so that we can actually listen to it, but let's skip to that for now. We're going to have a button and click start when that happens. So we're going to have a div here, and in the div we're going to have a button called white noise, and when you click it, we're going to start that. So white noise source, we're going to start it, and if I click it right now, nothing happens. And actually, I mean, you can only call start once, but like you can see, nothing really happens. And that's because we need to set up a gain, which is basically volume. And this will also allow us to make sure that we don't put things on a note so high that we actually kill your speakers, which is something that you can actually do. You can actually play sounds that are too like that they just break your speakers. I assume like there's some kind of protection against that, hopefully, but still we want to make sure I don't kill my headphones, because they are actually really nice and really expensive. Would be like a nice excuse to get some AirPods, but I don't think that's what we want. So we are going to create a gain, which is a fancy way of saying it's volume. We set the volume to 0.05, which I think is like half. We connect our source to the control, and we connect the control to the destination. This is like if we actually applied it into the speaker, and this is how we say we want our source to output to the speaker. So it's basically if we had an MP3 and we're plugging it into a speaker. So now, I don't know how loud this is going to be honest, but if I refresh this, you can kind of hear it. I don't know if that was loud enough. Let me put volume on max. I mean, yeah, obviously. Think you should be able to hear it. Let me know. Yeah, of course. And while I wait for you guys to tell me, React versus Vue. I learned Vue first because like Laravel came with Vue always, and I really enjoyed Vue. And now lately, I've been doing for the last few months. Thank you IRL Frogs for the follow. That's a really cool name, by the way. I've been using React a lot, especially with Next, and I really, really like it. It feels like more of a thing that I would build, like the APIs. Their JSX and stuff feels more intuitive to me, so but I think it's more of a question of preference more than anything, to be honest. So yeah, now for the $1 million question. Can you hear the white noise? We can hear the noise. Nice. Let me put the volume back down, and my music. So I think the next thing, I don't know, I read this, the last time I read this article was a year ago. But like, I think the next thing that we're going to sort out is like a kind of a hack, because like you can only start sources once, like as you see. So we're going to make a hack where we pause it and play it. I think that's what we're going to take care of. Yeah, here it is. An approach to this is to just create a new buffer every time. So you can create a buffer source and connect it every time, and that will just work because they don't require that much memory. I think that's what we're going to do now. So let's refactor this into a function that creates a new buffer every time. We can create the gain actually when we create the audio context, because this is kind of universal. And then we're going to have this function. And as far as I know, there's like a better way of doing this that is better for like memory usage, and that might happen later in the article, but for now something like this is enough. So here we are creating the buffer source and attaching it to our buffer, which means that we can move things around. So it's harder to hear now, and actually I'm not hearing it, but if you look at the icon there, you can see this web page is playing noise, or actually sound. So it works now, we don't have to reload every time, which is really nice. Now next, we're going to create a snare drum. What is a snare drum? This will probably get muted and copyrighted and stuff, but this... I mean, obviously. You can hear at the start. There's like this drum, which sounds super 8-bit. And that's what we're making now, because it turns out that is made from noise, which is really nice. All the drums are actually made from noise, I think, or at least most of them are, which makes it really easy for us. So now we need a lot of things here. We're going to use filters. We're going to use a big quad filter with high pass, which basically means it's going to take all the values and it's going to just cut through something, and everything that is above that it gets rid of. So it would be like if in this image we just basically got rid of something of every pixel that is darker than 0.5. Like if you remember here, the white pixels are 0, the entirely black pixels are 1. So we could cut this so that values only go up to 0.5, and we'll get an image that is a lot wider, which isn't really useful in terms of image, unless you're using it as masks for 3D stuff or something like that. But it's really useful on audio because it changes how it sounds. So we're going to create a filter for this. Snare filter. We make it high pass so that it gets rid of everything above a value. The value is going to be 1500 Hertz, and we connect that to the primary gain control. And since we are connecting it to the primary gain control, it's probably also going to affect the white noise. Or maybe not. Oh no, we need to connect it to the snare filter, never mind. So then in here, we're going to use the same buffer that we were before. This buffer that we created. But instead of that, we're going to, let's say, snare source. We're going to set our buffer. We're going to connect it to the snare filter instead of connecting it to the primary gain control automatically. What this means is that instead of just plugging your MP3 to the speaker, you connect it to something that then is plugged to the speaker, and that something is what makes the cropping. And then we're just going to start this snare source. So probably wasn't like an awesome idea to premiere my stream playlist the day that I'm working with sound. But anyways, this is how the white noise sound. Let's see. Like you can hear, it's still noise, but it sounds kind of different. It sounds like like high pitched, kind of. Like you can see it. Yeah, it's like higher in some weird sense. So yeah. That's kind of how snare drum works, and you would pitch it up and down, but that's the idea. Let's move that up. Let's move to something that is more interesting, in my opinion, which is a kick drum. And kick drums are basically this on the bass, which are really nice. So yeah, to do that again, we can do that with instead of a filter, we're going to use an oscillator now, and we'll talk about what that is. But let's bring back the music and set up everything that we need before that. Should probably find a setup when I can hear where I can hear things at the same volume that you can. So I have to toggle my own volume separately, and it's really annoying. Yeah, we're going to have kick drum. And for this we're going to need an oscillator, which is what we are going to start actually. Which means that I don't think this is done by a buffer. Like this is the one that is not derived from this random buffer that we made. It's derived by an oscillator. And on the oscillator, we set the value at time of 0, like at the start we want this to be a C note. Then we connect it to primary gain control, so that we connect it to our speaker so that we can actually hear it. And then we start it. And the problem with this, you'll hear, is that it doesn't stop. Like you can really hear that, but you can see the icon here, it doesn't disappear, it doesn't stop after a certain time, it just goes on endlessly. Or maybe you can hear, and it's my volume that I haven't. Yeah, you can hear it pretty well. So with all the others, let me reload. With this one, it stopped after 1 second, because we were using our buffer that we created here, and we set it to have a time length of 1 second. Here. And so here we are not really doing that. We're creating an oscillator, which we'll talk about what it is in a second, and then we're just setting a note and playing that, and we have not really no way to pause it. So what can we do? We can just set timeout, but the audio keeps time internally, so we can just do that. We can say we want the oscillator to stop after whatever time whatever the time is when we started, plus 0.5 seconds, I assume, so it should be half a second. That seems about right. So why are we using an oscillator? Because we are just playing a random note. We could just have used a buffer that sets the frequency to always be the same one. Thing about oscillators is they oscillate, and what that means is that it goes down over time. Like it has a fall, if it has a fade. And we can use that by setting, when we set the value at time, instead of setting it at 0, by the way, we are going to set this at 150, and that's going to sound a little different. That's lower pitched, so it sounds more than a kick drum. Instead of setting that at 0, which is basically going to say set this forever, we're going to set it at the current time. And this sounds the same, but this is important because now we're going to do an exponential ramp to value at time, which basically tells us later to basically we want to move to this value after this time, which is basically the end. So we're going to start on 150, but by the end we want to be at 0.0001, which I assume is here because you can't actually put 0, and it's like the minimum you can go. So it's going to start at this, but quickly it's an exponential curve, which if you're not good at maths like I am, is really, it really increases over time. This is kind of like doing easing for, or like a Bezier curves for CSS animations or transitions. Kind of like the same thing, but we have to use maths here. So now this is going to be a little bit annoying. It's like you can hear it. It kind of works like a kick drum, but there's a click at the end here. Like there's a, and then a at the end, which is done by your speaker, I think. Yeah. When we click the button, the speakers start to vibrate. As the pitch drops, they are still vibrating, but at a lower frequency. And when the oscillator stops, like when the sound stops, the speaker goes back to this position, which is too fast. It's like a fast change in pressure, which sounds like a click. And to fix that, we can create a gain node, another gain node, that we're going to connect to our primary gain node so that we can control the volume of this automatically. And so instead of setting the exponential ramp on the oscillator, we are going to set it on the gain. So I don't think this needs to be inside the button. I think we can put it after our other gain here. So we're going to have our kick gain, which is going to have a value of 1 at the start. Oh, actually, yes, we don't need this, at least this last line. So we're going to start it at 1, which is full volume, at least full volume relative to this one. And then we're going to slowly do the same operation that we were doing, but instead of doing it in the oscillator, like instead of changing the pitch, we're changing the volume, so there's not going to be a click. So we're going to set this on in here instead of this other one. And then instead of connecting to the primary gain control, we want to connect to the kick gain. And then we of course have to connect the kick gain to the primary gain control. So following our speaker metaphor, this is kind of like connecting our speaker to another speaker. Like if I have my main speaker, and instead of connecting my MP3 to that speaker, I connect it to another speaker which has an independent, or I guess it's not a speaker because it doesn't broadcast the sound, it forwards it to the other speaker, but it has like an independent volume and an independent volume. It's kind of like a source. Like here, when I'm on OBS, I can control the sound globally, like the sound of my voice plus the music, or I can control the sound of my voice independently and mute things. Like you have sources. So that's what we're doing here on code. So if I'm correct, And I am not. This doesn't work. Oh, it kind of does though. So the thing about this, first of all, is that we can only use it once. And to fix that, we're going to reset the value. So if we say set this to the, so this is the kick gain, set to value of 1 after this ends. So it works the first time, and it doesn't afterwards. I think. Let's see how they did this. I think they might be creating the gain every time on the event handler. Maybe. Let's see. They are creating, yeah, they are creating the gain in here. So they have a new gain every time. So, which means I can get rid of this now here. And here, oh, and they are also setting in on the doing the frequency on the oscillator at the same time, which I guess does make sense. And so if we try this now, it sounds like a kick drum. If we didn't have this on the oscillator like I had before, it's going to sound like more of like if you were hitting the membrane on a drum. And if you add it, now it sounds like more you are hitting something hard. It's like actually a kick drum. That's how kick drums sounds. So that's done. That's ready. Now we have more waveforms like we saw before. We are always using sine waves for now, but we are going to create square, triangles, sawtooth. For example, our snare right now sounds like this. That was really annoying. What if we made it sound like this? Which is also annoying, but less, and also sounds more like a kick drum. Like a snare drum, sorry. The key to doing that is using, where is it? Using the triangle oscillator, this one. So if we go to our snare, before we were just doing the usual thing, so it just sounds like noise but high pitch. We're going to first have a specific gain for the snare, kind of like how we did it with the drum, and that will allow us to fade it out over time, which gives it kind of like that sound. And so you can see here we're using the snare filter, which is here, so that's going to still be there, I think. Okay, so let's do the gain first. So we have our snare. Then we have the snare source. Okay, so here's what we're doing. We're creating a new gain. That gain is going to start at 1, so we can actually hear it. And that gain is going to ramp up to 0 after 0.2 seconds. We're connecting that gain, that source, to the gain, and we're connecting the gain to our filter, so we actually still have this high pass that actually gives it the snare sound. And then we're going to also drop the volume after 0.2 seconds so that we don't have the click. And we are going to have the start issue again because we need to pause it afterwards, like we were doing before here. So snare source like this. And it still sounds really annoying, but now it's shorter and more like to the point. Then we are doing the gain. We're going to try to get that snap sound using a triangle oscillator. So instead of having a sine wave, we're going to have a triangle wave. Like that. We also need to control the gain of that oscillator, since that's what we're going to be playing instead of the source, because the oscillator is going to be recreated on each run. So we create a separate gain for oscillator, set the value at 0.7 and go back to 0.1 after 1 second. We connect the oscillator to our gain, we connect the gain to our primary gain, we start the blah blah blah. Let's see if this works. So you'll hear it has that kind of like drum noise, but it still has like noise on top of it. And to be honest, I'm not exactly sure why that is, but we can hear what we did wrong. Let's see. So we have a snare source, which we are creating a new buffer source for and assigning our random buffer. Then we have a gain, which we are going to set at 1 and then fade out over time. We connect the source to the gain, we connect the gain to the filter, we start the source and we stop it after 2 seconds. That's part of it. Then we have an oscillator, which has a triangle and just has like the maximum volume. And then we have a gain for our snare oscillator, which starts at 0.7 and ends up at 0.01, and we connect everything together and make it play at the same time. And now it has more of this snare drum. So I think the issue that I had before is that I wasn't really coordinating this snare source and the oscillator at the same time, because you can hear that there are two sounds in here. Like on one, there's this one, and then at the same time there's this other one. And we are playing those two together to have this, which adds that white noise and also the kind of like a kick at the same time to get this snare effect. Great. So we have our 3 drums. I mean, this isn't really a drum. Let's try to make a hi-hat. So a hi-hat, it says that we are going to use we are going to learn how to connect an actual sound to it, like a sound file, because hi-hats are usually samples. Oh god, that was way too loud. But yeah, let's try to figure that out, because apparently it's not as easy as just having an audio tag. You have to do stuff and connect it to buffer source and gains and stuff. So let's figure that out.
Into the sunlight, we'll hide away all of our secrets, away for you in the darkness. There's no stopping us right now.
Okay, so it seems we have it now. I refactored this example, so instead of downloading the file every time we click the button, we do all the expensive operations, which is like fetching the file, converting it into an array buffer, and decoding the audio data once when we load the page, and then reuse that every time we click the button, so it's more efficient. Other than that, same code. We can also speed up and slow down the playback to change the pitch. But we are going to move into the really interesting stuff right now, which is notes. We know that notes have a frequency. Here we have the notes and the frequency. So now let's make a synth keyboard using JavaScript and buttons and Paint. So yeah. Let's do that and see if it works. There we go. Now we have, what I'm basically doing is I'm looping over this array. For each item I'm doing a button, which on click passes its frequency to this play node function, which basically creates a square wave that sets the value to the frequency that we're playing and connects itself to the gain control, and just play it for 1 second. And it works. It works. We have all our notes, including... And now finally, we're going to tackle envelopes, which are how the notes decay over time. So you can see here a diagram where we press the key, the amplitude starts rising, then it declines for a bit, like it does this instantly. It stays constant at this frame, and when it's released, it goes back to 0. So right now, it would just do this, and then do triangle things, and then go back. So we want to basically sustain it for a certain amount of time. And we have all these values, like the time of the attack, time of the decay. This is the attack, this is the decay, this is the sustain and release. So we can set times for all of this so that it sounds nicer. So let's do that. Let's first create a variable called now. And then we can do all of this. So first we're going to define all of these variables. Basically means time of attack, time of decay, time of sustain, and time of release. These all have to add up to 1 second, because otherwise it doesn't really make sense. Actually, that doesn't really make sense anyways. These are, as far as I know, percentages. I think that's how it works. Then we create our oscillator, we make it square, we create a gain. It's going to start at 0. It's going to go to 1 on the attack time. Then it's going to drop on the decay time to the level of sustain. And then on release is going to go back to 0. So if we play this now, sounds a little bit more not natural, because like it still sounds super synth, but it sounds more less like we just manifesting notes into the void, and more like we're playing some kind of instrument. To make it sound even more natural, we can add vibrato, which is when there's like a slight echo behind. And we can do that with another node in oscillator and gain. So we are going to set it to vibrate at 10 Hertz. And then I think... yeah, you can see there's like a slight vibration, which makes it sound more like some kind of instrument, actually, which is really, really cool. That's kind of like the end of this article. We're going to try and do something else, though, which is to create an analyzer, which basically displays and gives us a graph of what is happening. For example, here, you can see. Oh god, this is going to sound weird.
So you can see my voice is being like you can change.
That sounds weird as fuck, but you get the idea. We have
this.
visualization like this, and we want to make that with the thing we're using. The I don't know exactly how the API is connected, but yeah, we're going to create an analyzer. And then we're going to connect it to the audio source. And I think that should work. And then finally, we're going to need a canvas. We can actually there might be a thing that I missed. Now that I think about it, which is we kind of got rid of the actual this being derived by the actual node. It is kind of an oopsie. That should fix it. There we go. So now we can move on to the fun visualization stuff. So as I was saying, I can collapse all of this because we don't need it anymore. And we're going to have a canvas here. Which is here. This canvas, we'll make it wider afterwards. we're gonna set some things on the analyzer, like this. Then we're going to clear the canvas. For this I need to use React's useRef. So now we clear we get the context, which I'm not sure what the function for this was. I think it's like context, get context. And what arguments does this need? Content type. So to the there we go, and now we clear the rectangle. And then we have a draw function, which we'll have to move later, but we're going to define it here for now. And I'll explain all of this in a second. Okay, so first we are setting this up so that this function is run for every frame, so that it changes. Then we're getting the data from the analyzer to this data array we created here. It needs to be a let now that I think about it. Yeah, so we get the data. We first set all of the canvas to the same color to clear anything that was there in the previous frame. We set the line width to 2 and set the color to black so that we can actually paint. And we say we are going to begin painting. Then we need to check how wide we're going to need our bars to be, which we make a function of the width. So we divide the frequencies that we have between the width to get a proportional side. And then we loop over its frequency and set the slice to the color it needs to be. And this is going to break, I'm pretty sure. First of all, we don't have width and height. So let's fix that real quick. Let's set it to 100 now. And we'll update this. And this. And finally, the actual canvas. So we can update everything. Then if we give this another reload, height, I forgot to replace this one. So canvas height. And canvas is not defined. So let's do canvas ref current, I think. The best approach to get this. And let's give this another reload. And the issue now is that it doesn't really update because we haven't really connected it to where it needs to be connected. Let's see what happens if we connect it to our node. So here we're going to say connect this to the node gain. No, this needs to be a node, right? So I think what we're going to do is to connect the analyzer to the we're going to say, instead of connecting the primary gain control in there, we're going to connect this to the analyzer and then connect the analyzer to the destination. I don't think I need to do this the other way around. I think that should be enough. Let's see. And there we go. You can see here that it vibrates. And if we increase the size of this, maybe 500 and 1000, okay, so it only works at this size, but it works. You can see that we can see our white noise, the snare, the kick, and the hi-hat. I think the issue is probably related to this width and this height. go. So yeah, we managed to kind of do it. Let's just refactor this a little bit and push it up. I don't think there's that much else to do. Let's deploy this and finish everything off. And we get an error, which is not great. Draw is not defined. We didn't fix that last bug, so we'll have to deploy again. It seems like we messed up and deployed it to the site source org. So let's redeploy that again on my personal account. Shouldn't take that much time, really. Shouldn't really take more than half a minute or so. Yeah, there we go. And hopefully this time, yeah, there we go. It's live. There we go. So that's going to be it. I think some parts were a little boring, but in general I think I learned a lot about sound and stuff, which is really cool. So yeah, hopefully you enjoyed it too. Let me know and have fun. Bye.